Now today, there will be no mathematics in the today on the board today. No mathematics. Tomorrow, lots of maths. Today, none at all. Because we're doing pictures today. It's all to do with pictures. So I'm going to talk about graphics, about visualizations, and then we'll be doing as many as we can afterwards in the R practical upstairs. So graphics. So I think that statistics is about discovery. It's about finding out things. It's about discovering things. And there's various stages that we go through in discovery. We've got to have an important problem, something we're interested in trying to solve. And then we have to collect data, but we've got to have a good design, a good experiment, a good survey. We can't just collect rubbish. We've got to do things well. Then we've got to collect the data, we've got to design it, and then we've got to go out and get it so it's complete and accurate as much as possible. It never can be perfect, but we've got to do that. And then the next stage, which we're talking about today, is we've got to look at the data. Before we do any maths, before we do anything clever, we just look at it. To look, is there something strange? What's going on? What's happening? We've got to look at it. It's very easy to miss that out and go straight to the complicated statistics. No, you've got to look at it. Then, what we'll be talking about tomorrow and the rest of the week, we've got to model the data as if they are random variables arising from some distribution with some parameters. We want to make estimates or do tests about these parameters for formal statistical inference about, well, truth or what is really going on. Okay, so that's the stages, and we'll be doing these the rest of the week, but now we're doing this one. Now, looking at pictures, it's got a long history. Right, pie charts. We'll start off with pie charts. People familiar with pie charts? Yes, you see them. They're not used by scientists very much, but newspapers use them sometimes and things. They were very old. They're 200 years old. They were, I think, first invented by this Englishman, William Playfair. This was one of his pictures. I think this is a line across there, and it shows the Turkish Empire in 1780. How much of it was African, how much of it was European, and how much of it was in Asia. So the breakdown of the Turkish Empire. So we're going to see quite a lot of political statistics today. So it's quite good for part to whole comparisons. What sort of fraction is taken up? It's used today sometimes for communicating weather forecasts. The chance of rain. So this is when you've got a 70% chance of rain, 30% chance of no rain. And on some internet channels, weather channels, they'll show a little pie chart to show the probability of rain. Sometimes with little raindrops in here to show that. So that's a simple thing. You can do these. Oh, here's a pie chart. What do you think of this pie chart? This is from Fox News in the US. Do you think this is a good pie? Is there anything wrong with this pie chart? Who can say? Who'll tell me? What's wrong with this pie chart? Exactly. They should add up to 100. So that's from Fox News. I'm going to have many examples from Fox News in the US, which is famous for using the worst statistical graphics ever. It's great. There's a whole talk just on Fox News, how terrible. So this is one of the worst pie charts I've seen. But pie charts, this is an example from the internet, from the Wikipedia page, in fact, are quite interesting. Now, there's 3 pie charts. Can you tell the difference between those easily? What's the story there? What are the differences between them? Can you see that? What would you say? So yeah, what's the differences?
The red in the first one is less fun.
Yeah, so the red seems to go up along there. What about the ordering? Which are the biggest ones? How does the ordering? Any idea? Can you see anything clear? I mean, it's quite difficult, I think. The idea is that it's quite difficult. But if we draw these as a bar chart, suddenly we see that for these, as you said, the red gets bigger. The red is the smallest, and they're ordered like this. In the middle, they're all sort of all over the place. Down here, the order is completely reversed. And the idea of this is that that's actually difficult to see from the pie chart, but easy to see from the bar chart. So the bar chart is much better for making comparisons between percentages. If you've got a single percentage, a single breakdown, a pie chart can be quite good. So one pie chart is good, lots of pie charts is really bad. They're very bad for comparison. One is okay, so if you use them, you're only allowed one. They're very bad for comparing areas. Okay, so you can have pie charts, but you're allowed one. That's all. So pie charts. You can do pie charts. Oh, yeah, 3D pie charts. These are quite popular. You see these in publications. Many computer programs will give you a 3D pie chart. Do you like that pie chart? No, what's wrong with that one? What do people not like about it? Anybody say? Exactly. You can't see what, you got this, what's bigger than what. The whole point about a graphic is that it illustrates the numbers. This doesn't at all. You got that little tiny bit there. Yeah, look, that bit there is the same as this bit here. They're both 45,000. That bit is the same as that bit. They don't look anything like the same. So it's completely misleading. So 3D, and here's a nice one. Yeah, people who find you on Facebook. Can you read that? This is high school people you hated, college people you hated, work colleagues you hate, and actual friends in there. So I like the idea, but still, it's a nice picture, a nice idea, but still the graphic is terrible. Okay, so the first one, no 3D pie charts. In fact, no 3D. Anyone who uses 3D fails immediately. This is this is the rule. It's there's this phrase, a nice phrase, which I'm actually called chart junk. Chart junk is sort of unnecessary and distracting extra detail. That it just obscures the message. Okay, so that's a good one. Oh, I like this pie. So that's a real pie chart. Pie I've eaten, pie I've not yet eaten. So there's an example. Real science in action. Okay, you can do pie charts in R very easily. So arms crossing, which proportion? Hang on, what's what I do? Because you've got to be natural. It mustn't be naturally. Yeah. Here you go. Oh, yeah. Because otherwise you do it. If you think about it, you get it wrong. You can't think about it. Got to not think of it. Left on top. So I'm in the minority here. So in R, there's two things. All the data is in now. Arm crossing. Actually, I've now changed it just to lowercase. So you turn arm crossing was a left, right. You turn it into a table using that command, and that turns into a table of counts. And then you just do a pie of this table. You need a table of count, a sort of frequency table, and put in the title, and it gives you that. And you can do all sorts of extra things. You can color them, you can put in the percentage, you labels, you can even do 3D, but if you do, you've failed. So no 3D. But okay, so we can do pie charts if we want. Okay, now there's another sort of thing that looks a bit like a pie chart that you sometimes see. And this was first developed by Florence Nightingale. Now, 150 years ago, the British were fighting a war. They were with the French against the Russians. You're always trying to remember what the war was about, but I've forgotten what the war was about. But they were fighting there in the Crimea. And she was a nurse in a hospital here in what is now Istanbul, and she did all this nursing. And she wanted, when she came back, she wanted to display the benefits of nursing, of clean water and good food and taking care. And she invented these things called polar area charts. Actually, she didn't invent them. They had been used before, but she popularized them. Now, these are ones where it looks a bit like a pie chart, but where the slice represents, in this case, it's a month. Each slice is a month. And the area of the slice, the area represents the number of men that died. So we're seeing here that in July, this was the number, a lot of men dying here, and then at this period in the winter, huge numbers of men were dying. In January, enormous number of men dying here. And these are different causes of death. Different causes, are huge numbers of death. Up to March 1855, then she goes across to here, and the rates go down and down and down. And the point is that she actually arrived, I think, around here, but didn't get the hospital cleaned up until around here. And so what this is supposed to show is that the benefits of sanitation of the healthcare. These aren't the numbers, these are the rates per thousand. So per thousand men who came in, how many died? Okay, so to do that, she had to do some maths, because you have to work out from a number what the relevant area is, how long this line should be, so this area is the correct area. So polar area charts were popularized. You sometimes see them. Now here's one, actually, but this is not, I'm not sure if this is actually a pie chart for displaying football results. Actually, football predictions. In my last week, I talked about using statistics to give probabilities of football matches. This is the company that does that. They use statistical analysis to produce probabilities for the next week's football games. So this was Stoke versus Arsenal. Any Arsenal supporters here? Yay, some Arsenal supporters, right. So this is Stoke versus Arsenal. Last year, 2000, can you remember what happened? Can you remember the score? Yeah. So in the week beforehand, they used their mathematical models to say there's a 33% chance of Stoke winning. That's the size of the red segment. 29% chance of a draw. That's the chance of that segment. And Arsenal, 38% chance of Arsenal winning. So Arsenal were playing away, much better team, but playing away, so they have a disadvantage. They're not playing their home ground. And they produce probabilities for each of the possible results. So 12% chance of a 1-0 win for Arsenal, 9% of a 2-1 win, chance of 14% chance of a 1-1 draw, etc. Using the Poisson methods that I talked about last week. So this is using Poisson Distribution. And it's a pie chart because the width of the pie decides the area. Do people, I'm going to start doing some voting, because I'm going to be, do people like this? Think it's clear? Yeah or not? Yeah? No. Do not like, yeah, because a lot of people don't like this. Can you say why you don't like it? Is it difficult? Too much information. Yeah, it's it's a lot of information there, and I think people find it confusing. Once you get used to it, It's not too bad. What about these what about these though? What do you think these are? You know, it looks like Florence Nightingale's chart. Yeah, they're the probabilities. But look at that. That's 12% and that's 7%. Do you think that's a good representation of 12% and 7%? Why not? Yeah, exactly. The area, I mean, this is hugely bigger than that, which Florence Nightingale got right. You know, she did it by the area was proportional to the number. But they've done it wrong here because they've made the length of the, what's this called? Radius. You know, they made this proportional to 12% and that proportional to 7%. But when you turn it into an area, it gets it wrong. It's really misleading. And we're going to see that quite a few times of people getting the areas wrong. If you're using area, that's what's got to be proportional to the thing. So it's a bit of a mess, really, isn't it? Yeah. Okay, bar charts. On to bar charts. They're very familiar, nice. We've seen they can be very good for comparisons. I want to make a comparison of bar charts. You can look across. So this is the proportion who put left and right, or the numbers to put left and right. Okay, so it's very, very close, really. Now, bar charts again. This is, you can see some shading here to make them a bit more beautiful, or 3D. Okay, so do people, the shading, is that okay? Yeah, makes it a bit more attractive. There's still a sharp line there. You can see. Is this okay? No, terrible. Absolutely dreadful. You can't read. Where's the top? How does that correspond to the number? You know what? Is it that or something like that? You know, what is it? It's terrible, dreadful. And you see these things. Sorry? Which one, sorry?
Previous slide.
Yeah.
The sum of person isn't 100.
Oh yeah, sorry. This is the actual numbers of people, not the percentages. Yeah, it could be either, but I thought that was percentage. Now I thought, it only goes up to 25. Yeah, no, these are the actual numbers. So I should put frequency up here, perhaps. Yeah, it's not very well labelled. Okay, so that's okay. Terrible. Oh, what about this one? Another one from Fox News, comparing the Bush tax cuts. So that says 35% and that's 39.6%. What do we think of that one? What's wrong with it? Anything wrong with it? The scale. Yeah, that's what you're saying as well. That this doesn't bear any resemblance on the area. But it's because of the choice of scale. They've picked this one just below that to make it look like there's a huge difference. And there isn't a very big difference at all. So it's a really bad, that is a choice. So I could, if I'd done that and picked a scale there and drawn a line across there, it would make it look as if there's a huge difference between right and left. So for bar charts, the crucial thing is watch the scale. You should start from 0. You can't always start from 0, but you should start from 0 when possible. So that's, again, Fox News. It's incredible. They're so bad. It's but we haven't seen the worst. There is worse. There is worse to come from Fox News. So watch out. I mean, I look in the newspapers. You know, try to find anything or where you see these examples. Okay, this is a stacked bar chart, which is an alternative to a pie chart, but better for comparisons because it breaks up 100% into different groups. So this is what will happen for women. This is with cancer, and if you have chemotherapy, what will happen? So, you'll have side effects. Probably your hair will fall out or whatever. And if you don't have chemotherapy, what will happen? And this says, out of 100, after 5 years with chemotherapy, these will be alive. These will be dead from other causes, these will be dead because of cancer, and these will have their lives saved because of the therapy over 5 years. So some of those red become yellow. So a stacked bar chart. They're used quite a lot. They're easier to make comparisons than with a pie chart. I don't like them very much, but we might see those. Okay. Do people think those are clear or not? Do you like them? Clear? Yeah, not bad. Okay. What about that? No, I don't. That's the worst chart I've ever seen in my life. I mean, just terrible. It's got everything wrong. You know, it's just so wrong. It's a 3D and it's a mess. Dreadful. Okay. But you can just ask for these things and they appear. Actually, we should have a competition. Who can produce the worst graphic with the most, junk on it? Okay. So dot plots. You've seen that we get this strip chart instruction R is very nice for producing these, sort of dot diagrams to show the distribution of things. Very good. The trouble is, look, I did it on siblings, and what am I getting? What's happening here? So this is the number of siblings. Sorry? You can see what's happened. Look, you're getting, because there's quite a lot of people who had 3 siblings. Yeah, it's getting darker but we can't see how many because they're all going on at the same point. So we can't actually get a very bad idea we just don't know how many of those are. So the trick for this that we'll be playing with is that you wobble them around a bit. You give them you give them a slight offset to spread them out, so you can now see. Oh yes, there's quite a few around here and fewer down here, and it's called method equals jitter. You can jitter. I don't know what the default is, but you can make things jitter a lot or just a little bit. You control the amount of jitter. Method equals jitter, and you spread them about a bit. So that's quite a nice one. We'll be using some of those. Okay, scatter plots. Oh, we're nearly at the end. Okay, the first bit. Oh yeah, plotting height against, this is the standard scatter plot, height against foot length. And we see, what do we see? What do you think? Do you think they're related? Taller people have bigger feet? Yeah, sort of. We'll test that. It looks sort of go up a bit. Can anyone see, is there something odd about the picture? Can you spot something? You spot anything? Look down the bottom. Yeah, okay. What's that do? So this is, someone's got feet that are 8 centimeters long, but tiny. Has anyone really got these tiny feet? That's a real data point. So what do you think happened? What do you think happened? I don't think someone really has got feet 8 centimeters long. But they put down 8. Why do you think they put down 8? Yeah, well, what do they use? When they put down 8? It's the shoe size. I think someone put their shoe size down, which is very fair enough. So I think, I left it in there to illustrate what can happen. That suddenly you get a data point like that, and if you don't plot them, you might miss that. And it might include that in all your analyses, and so you find if you fit it, actually we'll do that later, we fit a line, it'll probably come down like this. And we find out this amazing relationship that, taller people have very small feet. We can discover all sorts of stupid things from this data. Okay. Now, the final trick then before the end, and this is something I just discovered. Now what I've done is to say, does this depend on gender, males and females? So I want to use different size dot, different coloured dot. Actually, the colouring isn't that good. What's it? I could have chosen the colour better. Red is men or women, and brown is male or female. I've forgotten which. So the first thing is to try to understand what's what. But the idea is to colour them differently. I've used big blobs. I think men is... men is red. They're bigger. The point is when you do this, it looks more like, maybe within women there's no relation, and within men there's no relation. Maybe the relationship is just because of being male or female, and that produces the relationship. So that's the kind of thing we're going to be analysing a lot. But just before we stop, there's a really neat trick here. I want to choose a different colour depending on the gender, a different colour. So I want this thing called plot colours. What colour is going to be plotted? Well, I only found out yesterday, I didn't know this, that what you do, gender is a vector that goes male, male, female, male, etc., etc., etc. And it's known as a factor. Now, a factor is a categorical variable. It's got categories. It's just not got numbers. It's just female or male. But what I want to do is to produce a new vector that goes 1, 1, 2, 1, etc., like that. That converts this to a string of numbers so they match, and then I can use these numbers. And amazingly, all I have to do is to go C1, 2, so that's a list of 1, 2, and then subscript it with gender, and it automatically produces this list. So it uses this factor to choose the relevant number. So it's really quite neat. I thought I was going to have to write a loop or something, but it's really quite a neat construction. And that means that I can, which you'll be doing, I can just choose the colour according to 1 or 2 according to the factor. Is that okay? Does that make sense? It's a neat way of doing that. Yep.
Now, how do you know that one is male or female?
Ah, yes. Exactly. I completely forgot. I suppose you have to check. Oh, it does it in the order of the factor. But you're right. I don't know. You need to keep track. That you know which is 1 and which is 2. It does it. The fact, if you go, if I type gender, it'll give me a list of the values that it takes on, and it'll do it in that order, male, female, and I can't remember what the order is. I'll show you how to order a factor later when we come to birthdays. Okay, so we'll leave that one. We'll come on back to that. Okay, it's a break now. Okay, this picture tells a very big story, I think, as you can tell. This is quite a famous graphic. I just downloaded it. It's using data right up to, I think, 2 months ago, latest data from Gapminder. And it's a very simple plot. For each country, it's just life expectancy at birth and income in dollars on a log scale. So it goes 500, 1,000, 2,000, 500, 10,000, 20,000, 50,000. And it's quite... Okay, first of all, how many variables are being plotted there? How much information is being given there? A lot. Can you count the variables? What is being shown? Yeah, life expectancy, in a way, health and wealth. What else is being shown? Population, yeah. This is the big thing. Making the size of the blob proportional to the population. So your eye is drawn to the big, look at India and China, Nigeria, Ethiopia, Bangladesh. Your eye is drawn to the big ones. There's a little Swaziland, Togo. Somebody can't see them very well, I'm sorry. South Sudan. So small, your eye's drawn to the bigger countries. So that's a third variable, the size of the country. What else is being shown? Yeah, the country and the location and the continent, yeah, using colour. So using colour and size and position. So that's 4 variables being shown there. And we'll see later that we can put a 5th. How can we put a 5th variable in there? How could we put time? This is only current state. How could we put history in there? Any ideas? Using modern technology, how could we put history in? We make them move. I show that we can make them move. So you put movement to represent time. So we'll see that later. I'll show you that later. But this is, what do you notice when you look at this? It's, what does it show? It's a really powerful graphic, I think. The first thing, the guy who developed this, Hans Rosling, who we'll see later, the first thing he emphasizes is the continuum. It's not just Europe and America and the rest. It's a complete band across. Sorry? Sorry? And progression, yeah. Well, then we see that, well, I'll show it later. We see the progression with things moving up, the steady progress up towards the top, from the bottom left to the top right. We'll see that later. Is there anything else notable about it, do you think? I mean, there's lots of stories there. But, yeah. Yeah, well, we will. Things do float. I don't know who's at the top. Monaco. Oh, these tiny little places, tiny little rich places like Liechtenstein, Luxembourg, Qatar is a little bit. Monaco, Hong Kong, Norway, of course. Where's the UK? Oh, there it is. Yeah. Down there. Yeah, I think the UK is going downwards, but UK is up there. France, Italy, Israel, Spain, South Korea, right up here. I don't know where North Korea. Where's North Korea? I don't know. And so, Portugal, Kazakhstan. The interesting thing is, because you can think of this as being a trend. Who is not following the trend? Which are the outliers? What we call outliers. Things that are sort of down here or up there. What would you point at? Yeah? South Africa. South Africa, here. Extraordinary outlier here. In terms of average wealth is very high, $8,000 per head per income. Health is very poor. Extraordinary. This is, essentially, down here you see an enormous measure of inequality when you're down. Huge inequality. This is staggering. And the point is that it also seems to happen for nations that are very rich in natural resources. Somebody is earning a lot of money. What this also shows, of course, is that averages, which we'll see later, are very can be very misleading. Because this is average income, average in the sense of adding up all the incomes and divided by the thing. This is not median income. This is not the income of the average person. So Angola, South Africa down here. What about up there? Up that corner. So Madagascar, having not a very big income, but having reasonable, people live a long time. What is it? Is it the food? Yeah. Usually Cuba, where's Cuba? Usually that's up here. There's Cuba up there. Cuba is usually up there because people in Cuba have a fantastic healthcare system. They've got no money but a fantastic healthcare system. So Cuba for a long time was up there. Now it's actually, they're getting a bit richer, but it used to be up here all the time, Cuba. Vietnam as well is extraordinary. People living for a very long time now in Vietnam. Sorry? Zimbabwe. Well, down here we have the nations that have been, tend to be a lot of civil disturbance, war, DR Congo, Sierra Leone, etc., Afghanistan, down here. Sorry? DRC is actually it's almost off the graph, unfortunately. Yeah.
Direct relation between wealth and
exactly, there's a strong correlation. Okay, we'll see this later when we'll go into this in more detail. But what I want to show there was how much you can get into a scatter plot. Because all it is a scatter plot, but it carries a huge amount of interesting. Okay. Next one. So, and all this data is downloadable. So if people want to do some project, we're going to start thinking about projects for next week. There's fantastic data sets that are available to do your own analysis on. About all this data is downloadable from the website. It's extraordinary. So line graphs. Now this is the place, there's a site which I refer to, Google Public Data, which just contains downloadable data sets of vast amounts of this international data that's available. And they will, a lot of plots, and we'll see some, I'll show some pictures of it, what's happening later on with that. So line graphs, these are standard things. What's this thing? This is saying that China, this is future, looking into the future. I don't know how they invent these, but this is what they're assuming is going to happen over the next 50 years, that China is going to become incredibly rich, and India is going to become very rich, and Europe's just going to go along there. It hasn't. Oh, it's not interesting. It hasn't got Africa, and it doesn't have Brazil in there. Brazil, everyone's going to be stinking rich in Brazil as well. Isn't Brazil going to do this? So, and poor old Europe's going to fade away. So they're simple line graphs, very easy to interpret. Again, no use of colour. Quite nice use of colour. But there's other ways we can do. We could make some lines thicker than each other. We can use different shadings. We can do all sorts of things with lines. Now, here's a Fox News line graph. This is unemployment rate under Obama. Now, can anyone see anything strange about that graph? Have a look at that graph. Study that graph. You look at the end of it. Anyone see anything strange? That point is not in the right position because it's just not in the right position. They just moved it up. It's incredible. No, yeah, exactly. That's exactly what you said. That point should be lower than that point. And it's well spotted. Very nicely spotted. Nice bit of detective work there. Yeah. It's complete lies. It's extraordinary. The vertical scale, yeah, the points have no resemblance to the vertical scale at all. They just put the points where they wanted to. That's the actual graph, looking like this. But they didn't want to show this decline, so they just moved the data point up there. Isn't it wonderful? You know, you see this is a national news organisation. So that's my final Fox News example for misleading data. Now, again, if any of you do this, that's it, fail immediately. No fiddling the data. So it just shows you've got to look, you've got to watch what's going on. You can't trust anybody in this world. This is an interesting one. This is one the British Bank of England uses. The Bank of England uses this idea of a line graph, but they actually put uncertainty around the predictions. You see the Google ones I showed just said, this is what China is going to do, as if they knew. Of course they don't know. So what these do is, actually they don't even put a central line. What this is saying, this was a prediction made in 2007 of what they thought growth was going to be, economic growth. So 0, 1%, 2%, 3%. And they produce what's called a fan chart, where they blur it. They just put a blurring around it. Now you can do these things in R as well. If people, you blur it. So you say, well, we think it's going to be around here, but we're uncertain about it. And each of these little intervals contains 5% of the data, of the belief, really, of where it's going to go. And they don't even know what happened in the past either. This is what the Office of National Statistics says happened, but in fact they're uncertain about actually the history. They're uncertain about the past. So they don't know what happened, and they don't know what's going to happen in the future. But they still, they get a lot of criticism for this. People say, well, you don't seem to know anything. And actually, they knew even less, because look at the date, this is 2007. Oops, that's what actually happened. Went down here. It just disappeared. This is before the financial crash. Growth just plummeted. The whole country's in recession now, still is. So our economy is in a complete mess, and they completely missed it. This was a total surprise. Actually, it's not a total surprise because they actually leave 5% down here as a probability. This only contains 90% of their probability, and they leave the rest. So this is the 90% interval. We'll be dealing with this a lot, 90% and 95% intervals. So it means that they actually said, well, there's a 5% chance something will happen and we don't know. So that's how they cover themselves. They said they didn't apologize about this. They said, well, that's it. No, sorry, these things happen. No apologies at all. That was just fine. Okay, so there's some other ideas of putting uncertainty. Okay, small multiples. We're going to be seeing a few of these. And this is something that this guy Tufter, which I'll refer to later, emphasized. The idea of having lots of plots. So you can use your eye. The human eye is really good at looking around plots and saying, that's a strange one, that's odd. So this is not a very multiple, there's only 2 here, but putting lots of scatter plots or something like that is a very popular thing to do. And so, for example, here it's very simple. This is just number of siblings among females, how many siblings females have got, and how many siblings males have got. And it's not, actually I should have put them underneath each other. It's quite easy to do. Yes, very bad. Much easier to compare when they're underneath than side by side. There's a display command. So you'll do that. I've given the code for doing this. You just do histogram, twiddle siblings, and this is conditioned on gender. A given gender, how many siblings? Very easy command, and you can but you can make the displays different. And we'll be doing these, giving you these instructions for doing this. It's odd. Let's put the scale up there and down there. It's quite strange, isn't it? Never mind. It means the scale isn't repeated, I suppose. Okay, so we're doing that. Lots of plots. Very popular thing to do. Okay, now we're getting on to the end. Spatial data. There's always a lot of use of maps. Putting data onto maps is very powerful. This is an old one from 18 something or other, where on a map of France with pie charts on the map. I think this is from about 1850, but it's about 150 years old. People were drawing this and putting a pie chart in areas of France. And they're using different size pie charts. It's a really cool design. That was from 150 years ago. All done by hand. No computers, nothing. Isn't that cool? It was a brilliant... we'll see some other old graphics. I love these old graphics. They're beautiful. So that's really quite cool. Arranging... you can do this. There's an R command for arranging numbers on maps. So if we have some geographical data, we could do that. So, for example, okay, this is some data from South Africa. This is not the latest crime figures that came out last week, but this is saying South Africa murder rates, the lightest are the safest, the darkest are the most dangerous, 10 per 10,000. Youth sexual assault, house robbery, most dangerous areas, again marked. Income inequality, so highest inequality across there. So these are the sort of standard ways we display data. Can anyone think of any problems with these kind of displays? Anything, why this might not be a good way to display the data? It's very popular. What? Anybody think of problems with it? I suppose there's 2 things. Are there problems with the data and there are problems with the display? Do you think there's problems with the data? You need to know something about, exactly, you need to know something about the places and geography. Yes, exactly. I think it's actually really difficult to see what is going on in Cape Town and Johannesburg. The big areas, you can't see what's going on there. It's impossible to see. And so it's a general problem with maps, is that, so what about these areas in the middle, huge areas like this, which are taking up a lot of the map? I mean, I don't know a lot about South Africa, but I don't think there's anybody here. Does anyone live in these places very much? About few people. Is one of the problems with the map is that the eye is drawn to the areas where nobody's there. And the cities where everybody's in there, you can't see what's going on. So we're actually drawn, we're looking at probably what is probably quite unimportant areas without seeing what is important, which is where the people are. So it's the problem with the map is that it focuses on the area of the country, not on the population, where people are, where they want to know, what the crime rates are for them or for people. So it's a real problem with mapping things when you have, it's very bad for identifying what's going on in the centres of population. I mean, you could blow them up. You could blow up areas maybe. But the other thing is, do we believe any of this data? Do we believe this? I think I wonder how accurate it is. So we'll talk about that later. Okay. All right. This is the final the thing I wanted to show you. Oh well, and I'll show you Hans Rosling as well. I mentioned movement. That's the new thing one could do. And I'd like to just show you some examples of that. First of all, a little bit of work we did with taking the Florence Nightingale work. We did this. Oh, this is our website, Understanding Uncertainty. Understanding Uncertainty. So we did this work on Florence Nightingale, taking this picture and turning it into that, which actually now, it looks like the original, but actually is an animation which shows over time what happened. So I can repeat that. In fact, we can go backwards in time. Don't know why, but you can go backwards in time. So that's the idea, is to show, usually movement represents time. It's a very simple example. And we changed we did the original. Oh yes, this shows them just going round and round in a circle. But the other idea that people have suggested, oh, what's this one? Oh, this shows the number of people dying in different times. Oh, that's cool. What do you think of that? So what a funny picture. I didn't know we had that. What do you think? So these are the number of people dying. What do you think of that? It's not very smooth, is it? It's not very good. No, I don't like that. You don't really like it. No. Well, but this one? What about just a simple bar chart, though? Really? Yeah? Why not this? I mean, I think this is as good as anything, really. Yeah. Nice bar chart, showing the different things. You see the trends, you see it coming in nicely. That's good enough, really. You didn't need all the clever stuff, I don't think. Okay, so that's an example of the fact that you can take the same information and maybe one of the simplest things is the best. Just an ordinary bar chart. Okay, so that's one example. Let me just go to a different one now. If I go to Google, and what was I doing? Google public data. Okay, so they Public Data Explorer, which has a lot to do with world development and things like this. So they have got this nice example. Okay, now this is one where, for different countries, here we've got life expectancy and fertility rate. So this is average number of children per mother, per woman, and this is how long people live. So this is healthier, and that's more children over time. And then they look at this. Let's go back. Whoa, I don't want to go there. Yeah. So let's go. We could go back in time. Oh no, hang on. I think we can. What have I done here? Oh yeah, here we go. To 40 years ago, it was like that, with a few countries in Europe red with high life expectancy and low fertility. So 2 children per woman, running 2.5, living till about 70. But with a lot of the with India and China things back up here, 5, 6 children and low life expectancy. And what they illustrate here is what happened over the next 40 years. So China coming down. This is now, and the one child policy. India. Yeah, look, everybody. Isn't that amazing? Do you want to see that? Do you want to see that again? Yeah, I mean, it goes very quickly. Okay, look, so it's a smooth, just finally down, smooth trend. We could look at particular countries if we want to where they are. Yeah, so you can see, yeah, some people zipping all strange. Yeah, you wonder, well, sometimes if there's a big war or something like that, and suddenly life expectancy can change. So this enables you to look at different sets of data, to choose different countries, and to do all these, look at these analyses, etc., etc. Okay, can I do a final one? And I'm going to need some sound on this. This is Hans Rosling. I hope will work.
Visualization is right at the heart of my own work too. I teach global health. And I know having the data is not enough. I have to show it in ways people both enjoy and understand. Now, I'm going to try something I've never done before. Animating the data in real space, with a bit of technical assistance from the crew.
So, here we go. First, an axis for health, life expectancy, from 25 years to 75 years. And down here, an axis for wealth, income per person, $400, $4,000, and $40,000. So, down here is poor and sick, and up here is rich and healthy. Now, I'm going to show you the world 200 years ago, in 1810. Here come all the countries. Europe brown, Asia red, Middle East green, Africa south of Sahara blue, and the Americas yellow. And the size of the country bubbles show the size of the population. And in 1810, it was pretty crowded down there, wasn't it? All countries were sick and poor. Life expectancy were below 40 in all countries. And only the UK and the Netherlands were slightly better off, but not much. And now, why start the world? The Industrial Revolution makes countries in Europe and elsewhere move away from the rest. But the colonized countries in Asia and Africa, they are stuck down there. And eventually, the Western countries get healthier and healthier. And now we slow down to show the impact of the First World War and the Spanish flu epidemic. What a catastrophe! And now I speed up through the 1920s and the 1930s. And in spite of the Great Depression, Western countries forge on towards greater wealth and health. Japan and some others try to follow, but most countries stay down here. Now, after the tragedies of the Second World War, we stop a bit to look at the world in 1948. 1948 was a great year. The war was over, Sweden topped the medal table at the Winter Olympics, and I was born. But the differences between the countries of the world was wider than ever. United States was in the front, Japan was catching up. Brazil was way behind, Iran was getting a little richer from oil, but still had short lives. And the Asian giants, China, India, Pakistan, Bangladesh and Indonesia, they were still poor and sick down here. But look what is about to happen. Here we go again. In my lifetime, former colonies gained independence, and then finally they started to get healthier and healthier and healthier. And in the 1970s, then countries in Asia and Latin America started to catch up with the Western countries. They became the emerging economies. Some in Africa follows. Some Africans were stuck in civil war and others hit by HIV. And now we can see the world today in the most up-to-date statistics. Most people today live in the middle. But there are huge differences at the same time between the best of countries and the worst of countries. And there are also huge inequalities within countries. These bubbles show country averages, but I can split them. Take China, I can split it into provinces. There goes Shanghai. It has the same wealth and health as Italy today. And there is the poor inland province Guizhou. It is like Pakistan. And if I split it further, the rural parts are like Ghana in Africa.
And yet, despite the enormous disparities today, we have seen 200 years of remarkable progress. That huge historical gap between the West and the rest is now closing. We have become an entirely new converging world. And I see a clear trend into the future. With aid, trade, green technology and peace, it's fully possible that everyone can make it to the healthy, wealthy corner.
Well, what you just seen in the last few minutes is a story of 200 countries shown over 200 years and beyond. It involved plotting of 120,000 numbers. Pretty neat, huh?
Yeah, okay. So, yeah, that's trying to make statistics interesting. Okay. Yeah. Oh, it's YouTube. Yeah, it's called this one. It's had 5.5 million hits on YouTube. I mean, that's nearly as many as, there's more than Justin Bieber. So it's a 5.5 million hits for a statistics talk, which is quite impressive. Yeah. So you see, and it's a scatter plot, but it's telling a story. You see multiple. So there's 2 dimensions. Then they're using colour for geography. They're using size, population, and they're using movement for time. So there's 5 dimensions being shown simultaneously, and we can understand it. We can follow that 5-dimensional vector being displayed, and we can understand it. Very powerful. Very powerful. I'm sorry about the comments about the gong. Yeah. So, yeah, any questions on that kind of thing? What do people think? Any comments on that? Yeah. Yeah, it is quite powerful. So if people are interested in this kind of stuff, then there's all this data he's showing is downloadable, and we can play with things. So, okay, let's just carry on then before we go upstairs to try some of the things. What we're going to do, of course, we won't look quite as good as that, but never mind. Okay, so there's some use of animation, use of movement, very powerful. Okay, so the Public Data Explorer I described. Okay, so just to finish off, this is moving towards, in a way, making data really sort of attractive, really quite journalistic style, telling a story. And there's a word for that now with infographics. Ugly word, but it's used a lot in it's also called data journalism. And it's when you use images, colour, layout, movement to increase the impact, to grab attention of non-statisticians. And they almost become works of art, increasingly popular. So I'd just like to show some of those. One of the is worth. David McCandless is a star of this. He's got a book and a website called Information is Beautiful. This one isn't too dramatic, I don't think. It just displays different amounts of radiation. These are in sieverts, I think 100,000, what the effect of 100,000. And it's just showing a way of showing numbers using a graphic, using colour, using layout to be quite an attractive thing to read. That's not great. This is an interesting one, which I just saw. This is about Chick's rule. This is about gender balance on social networking sites. So it's about which sites. So in Facebook, 58% are women rather than 42% men. So these are the sites in which there's more women than men, matriarchy, and these are the ones where there's more men than women. So there's more men than women on YouTube, LinkedIn, Flickr, etc. It's Google+, Delicious, Spotify, and more women than men on more women on Twitter, Facebook, all these. Half of these I haven't heard of. And so basically, all he's doing is showing a whole lot of percentages. You know, it's just percentage men or women. But he's illustrating it by using the little icons, using the different colours, using quite neat, the label is given in the style of the program itself. So, it's quite clever use of illustrations to produce what's really just a set of numbers. I don't know what the point of that is at all. Never mind. Now this is a terrible, okay, what do you think of this infographic? Again, what's wrong with this one? Anything wrong? This is from the Times in London, the important newspaper. Infographic. What do you think? Yeah, what do you think?
Does that have anything to do with that?
Well, yeah, I mean, that's 24% of patent applications, and this is 48%. What do they? Exactly. Yeah. So what they've done is take the height is twice that. So they've done the height proportional to the number. But of course the area is now 4 times. That's 4 times as big as that. So completely misleading again. Because they've done it, they've used an area, it's not area. So that's a really terrible graphic from the Times. This is supposed to be the best graphic ever done in the history of statistics. I think it shows, this count that I mentioned, this is amazing. This was done in 1870. This shows Napoleon marching on Moscow in 1812. And if you don't know about the story, but this is a map of Russia. And Napoleon started off with this army of, I think, 400,000 men. And so the width is the number of men. And he marched across, he marched. Some of them split off. Lots of them got lost, died of disease. And he got to here, he had a battle, from Murmansk, I think he had a battle. And only about 100,000 actually got to Moscow. But the Russians had abandoned Moscow and burnt it down. And so he got there in about October, I think it was, or November. And there was nobody there. So he turned around and went home again. There's nobody there. They all just left. And so he turned around. And at this point, this is him marching home. The winter came in. This shows the temperature. And the temperature dropped. This is minus 30 degrees, minus 11, minus 21. Dropped, and all the men froze to death. And then they crossed this river. They lost half the army, died just crossing this river. And he got back, I think, with 6,000 men. He started off with 400,000, and only 6,000 got back. Unbelievable. Having walked all the way from Paris to Moscow and back. Sorry, yeah? The vertical, this is just space. So it's a map. So this is longitude and latitude. And then we've got the width is the number of men. We've got time, and then we've got temperature. So we've got space, we've got number of men, we've got time, we've got temperature. So I guess that's 5 variables shown on there. And that's supposed to be, it's held up as being a really good infographic, as telling a very vivid story of this disaster, military disaster. Okay, so just to finish off, just a few examples of people using, I won't do this, weather, for weather uncertainty. A lot of statistical graphics used for weather. So this is hurricanes in the US. What they show here, this is predicting where the hurricane will go. And they put this is the main prediction. But a bit like the Bank of England, they put uncertainty around it. And it's called the cone of uncertainty. The cone of uncertainty. And what they say is that there's a 66% chance it'll be in the white rather than outside. So it's 2 to 1 chance it'll be in the white. And people don't understand this. It's had a lot of criticism because it looks like they think it'll definitely be along here. And so people who live there think, I'm all right. And then the hurricane destroys their house and they get angry. So in the latest ones, they've dropped the central prediction. They just say it could be in here. We think there's 2 to 1 chance, 66% chance it'll be in here rather than outside. This is Hurricane Irene. But another way of showing the uncertainty, which I like this one, well, I shouldn't say I like it, is just to show possible paths. So this is different computer models come up with different projections. So these are possible paths. They're, it's called a spaghetti plot, because it looks like spaghetti. And this was used on national news in the US as possible paths. Do people, I gave it away, I like this, but do people like this? Think it's a good way to visualize uncertainty? Yeah? Yeah, I like, well, yeah, I quite like that one. Okay, but this was near where I live. A few years ago there was a big storm, the bus just got blown off the road in the wind, and you could say, how well was this predicted 5 days beforehand? Now, this is an example of small multiples. This is what the weather forecasters produce. They call them postage stamps. These are 25, hang on, how many, what is that? Yeah, 24 different predictions of what might happen with the weather over the next 5 days. So they run the computer model 24 times from slightly different starting points. It's all based on differential equations, and then they make these predictions. So these are, and they're very different. This one shows very high pressure here. It could be a big storm here. This one shows nothing much at all. Everything's going to be just fine. Nothing's going to happen. This one shows, again, big storms over Scotland. You use the eye to quickly identify those that look different from others. So they've very little idea of what might happen. But as a reasonable, and what they do actually is if 2 of them predict a hurricane, that's 2 out of 25, they might say that's an 8% chance of a hurricane. So this is how they produce probabilities for weather forecasts and rain. So this is where the probabilities come from weather forecasts. Ah yes, this is again is just showing for predictions about wind speed. These are the probabilities of getting a storm, particular wind speed there. Again, used by these use of graphics, use of color, movement by weather forecasters. Okay, just to finally finish. This is another graphic. Have people seen tag clouds, where you represent, by the size of a word, you represent its prominence? In this case, are there any tennis fans here? Are people interested in tennis? Oh, good, right. This shows the probability, this last year's Wimbledon, the probability of each of these people winning Wimbledon. From a bookmaker beforehand, from a betting company beforehand. Where the size of the font, the size of the word represents the probability. So it's actually a way of showing a big probability vector in one graphic. These are called word clouds, and there are programs, you can put your data into programs on the web, it'll produce these for you. Or this one's called a tree map, and this is where the area is proportional to the probability. So the bigger ones show the biggest chance of winning. So he's got very little chance of winning down here, up to Nadal, and I can't remember who won. Federer won, I think. Yeah. So those are the chances. So that tree map, again, you can put values into a computer program and it'll produce these for you. I think it's probably in R as well. I quite like. People like that? Think that's good? Yeah, it's cool, isn't it? Good, really hits you. Good. Yeah. Okay, so just to finish off, some sources. This book is very good. There's 3 books by him which have got beautiful graphics in, and some terrible ones as well. There's a website called Many Eyes where you can put data in and it'll produce all these lovely coloured plots for you. If you want to put these onto your website, Google provides HTML templates for many graphics where you can put your data in and produce these beautiful graphics for your website. So there's in the Google developers site. They're really cool, very nice stuff. There's the Google public documents one as well. Okay, and the other thing is we're now going to go and try a lot of this stuff in R. Now, we're going to give, there's some code in R to produce the things that I've produced. And so we want you to run those, and then we will write up on the board various other things we want you to try. And then really you can explore. We would quite, to make the graphics more beautiful, to use color, to put labels, because we've only put the simplest ones in. And so we'd really like you to try these because we will be using this a lot. Now, if you want, there's the help command, but also there are some very good tutorials. Here's a list, but if you just Google R tutorial or R graphics tutorial, there are some very good examples. This is for real enthusiasts. This is for serious enthusiasts. But this is a nice one, and these are good. So there's lots of good tutorials. Now, so I think that's it. Any questions? Because we'll go upstairs now and start trying to produce some of these things. Obviously, maybe we won't be able to produce all the ones with the wiggly, all the bubbles. But there are programs on there where you can, if you've got data, will do those bubbles for you. They're called bubble plots. You've got the bubbles going on. So if you've got some data, you can produce these things. Okay, thank you very much indeed. Let's head upstairs and do some work. And tomorrow, there's lots of maths. For those, I'm sure you've missed it. And so, lots of maths tomorrow.